Hey guys, let's go ahead and practice multiplying by our powers of 10. So we're going to start with 124 times 10. This is a nice easy one. So remember, we're just going to multiply our non-zero digits first. So we're going to do 124 times 1 and then just add 1 0. So that will give us 1,240. Next, to multiply 124 times 100, we're going to do the same thing. Multiply your non-zero digits first. So 124 times 1 is, of course, 124. And then I have 2 zeros to add. So my product is going to be 12,400. All right, next we're going to take 124 divided by 10. And for this one, I need to go ahead and show my decimal point, even though it's understood to be there with all whole numbers. I'm going to actually show it here. Now I'm going to divide by 10, which means my decimal point is going to move over one spot to the left to make my number smaller. So my quotient, or my answer, will be 12 and 4/10. Last, to divide 124 divided by 100, I'm going to add my decimal point because that's understood to be there after the ones place. I'm dividing by 100, which means my decimal point needs to move over 2 place value spots to the left. So my quotient will be 1 24/100. Okay, next for my measurement problem, I'm going to convert 37 centimeters divided by 100 centimeters in each meter, and that will tell me how many meters I have. Now, when I say I want you to upload supporting work, I'm talking about actually showing me where you wrote the problem, wrote the number with the decimal point, and then moved the decimal point over 2 place value positions to show that you divided by 100. So that means that your quotient is 37 hundredths of a meter, meaning not a whole meter. It's actually less than half a meter. All right, now I'm going to take 50 kilometers and I'm going to convert that to meters. So I'm going to have to multiply. Okay, there's 1,000 meters in a kilometer, which makes sense because kilo means 1,000. So I'm going to multiply 50 times 1,000. So let's see, let's go ahead and multiply our non-zero digits first. And there's a couple ways you can do this, but to stick with the strategy I showed you before, 5 times 1 is 5, and now I have to count up my zeros. I have 1, 2, 3, 4 zeros. So my product is going to be 50,000 meters. Okay, now we're going to identify an equivalent fraction for 5/9. This means that it's going to be a fraction with the same value, but a different numerator and different denominator, without changing the size of the whole. So I'm going to divide my whole into 9 equal pieces. And then I'm going to shade in 5 of those pieces. So my portion will be 5 out of 9 equal pieces. 1, 2, 3, 4, 5. Now, in order to come up with an equivalent fraction, I have to cut my pieces into smaller portions without changing the size of the whole. So if I cut each 9th in half, which is effectively multiplying my denominator and my numerator times 2. Now I have a total of 18 equal pieces, and 10 of them are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10/18 is equivalent to 5 out of 9 if the whole remains unchanged. Okay, next we're going to work on our rounding. 456 and 531 thousandths. We're going to round that to the nearest tenth first. Step 1, locate the digit in the tenths place. Its next door neighbor is what's going to tell you how to round. So since our digit in the hundredths place is a 3, remember our rhyme, 4 or less, let it rest. So that means that this is going to change to a 0, this is going to change to a 0, and our 5 is just going to remain the same. So that's how we round that number to the nearest tenth. One mistake I'm noticing is that kids are leaving behind these digits. So make sure that when you round a number to the nearest tenth, you bring along all of the digits, and then it's just the ones after the tenth place that revert to zeros. Next, we're going to round 456 and 531 thousandths to the nearest whole number. So step 1, locate the digit in the ones place. Its next door neighbor is what tells you how to round. So here we have a 5. 5 or more go up a floor. So this digit reverts to a 0, as do all of the ones after it. This digit rounds up. We're going up a floor with our 6. So this will round to 457. Last one, 456 and 531 thousandths, rounded to the nearest tens place. Locate the digit in your tens place. Locate its next door neighbor, which is a 6. So that means 5 or more go up a floor. This digit goes up a floor, and all of these digits revert to zeros. Okay, now we're going to subtract 7 3/4 minus 3 7/8. And the first thing that I notice, since I'm going to be subtracting fractions, I see that they do not yet have common denominators, so I need to fix that. Our whole numbers can remain the same, and we just need to change this. This is an easy one to change, because if I cut it into 4 equal pieces and I shade 3 of them, I can see that it's going to be a simple thing for me just to cut each one of these in half, which is the same as multiplying my denominator and my numerator times 2. So now instead of 4 equal pieces, I have 8 equal pieces with 6 of them shaded. 1, 2, 3, 4, 5, 6. Okay, and then my 7/8 remains the same. Okay, so now I just need to subtract these. Here's a great opportunity for me to show you how to do this using an area model. That's something that I know is going to come up on your tests when you are starting to take tests about fractions. So when we're subtracting 7 6/8, we're going to start with that total, right? 1, 2, 3, 4, 5, 6, 7, and 6/8. That's what we're starting with. And then we're going to subtract 3 7/8 from that. Sorry, I misspoke. 7 6/8 minus 3 7/8. So I'm going to cross out 3 wholes, 1, 2, 3. And then I need to cross out 7/8 and see how much is left. And that kind of brings us to an interesting question of how to borrow or regroup when you're working with fractions. So I've already crossed out my 3, and now I'm going to cross out 7/8. This is gone. That's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Now I can't cross this out because I don't have it to begin with. It's not part of this initial first amount. So that means that I need to go to my next whole and divide that into 8 equal pieces in order to take away my last 8th. So now I've taken away 1, 2, 3, 4, 5, 6, 7/8. And what do we have? what do we have left? We have 1, 2, 3, 4, 5, 6, 7/8 of a hole, and then 1, 2, 3 holes is what is left. Okay, now I'm going to make one final comment, which is that if I see this answer in decimal form, I'm going to know you did it using a calculator and not the way I'm teaching you. So I do not want to see this solved in decimal form. I want to see the area model. Even though it's extra work, it's better for your brain, trust me.